It's my Good evening to everyone. It's my privilege to introduce today's distinguished speaker, Professor Chandan Chakraborty, a leading academic and researcher in the field of artificial intelligence and interdisciplinary innovation. Professor Chakraborty currently serves as a professor in the Department of Computer Science and Engineering at the National Institute of Teaching, Teachers Training Research, NITTTR Kolkata. His academic journey is an impressive as his contributions beginning with a degree in statistics honors from Narendrapur Ramakrishna Mission Residential College, followed by a master's in applied statistics and informatics from IIT Bombay, and culminating in a PhD from IIT Kharagpur. He is a passionate educator and mentor, deeply involved in faculty development programs, national mentorship initiatives, and short-term training courses in cutting-edge areas such as AI, machine learning, deep learning, data science, and IoT. His work is closely aligned with the goals of NEP 2020, driving quality enhancement in technical education across India. On the research front, Professor Chakraborty is renowned for his contributions to computational medical imaging, particularly in career diagnosis using AI and deep learning models. His scholarly outputs includes over 105 journal publications, multiple book chapters, and presentations at national international conferences. He also holds 2 US and 2 Indian patents, reflecting his commitment to innovation and applied research. His accolades include the Young Scientist Award presented by Dr. APJ Abdul Kalam, the Young Researchers Award from the Department of Atomic Energy, and the Fast Track Young Scientist Award by DST, Government of India. He was also selected for the Biomedical Fellowship by ICMR for his pioneering work in biomedical engineering. Please join me in welcoming Professor Chandan Chakraborty, whose insights today promise to inspire and elevate our understanding of how AI and interdisciplinary research can transform education and healthcare. Welcome, sir. Please, good evening. Welcome, sir. Please, you can start, sir. You can continue.
Good evening to everybody. Let me first, am I audible, right?
Yes, sir.
Okay, madam, thank you. So, first of all, I'm very much thankful to Dr. Vasundhara and her whole team, especially inviting me to, talk on a topic of interest like artificial intelligence in climate change as part of your ongoing very fruitful program under AICTE ATAL FDP. So this evening, I understand that currently whatever the topics are roaming around at this moment, application of artificial intelligence in varieties of directions, because the whole nation is also, focusing on this area specifically with special emphasis such that the country can go forward at faster rate efficiently to compete with the other developed countries. So with this national objective, which is aligned also as a part of this ATAL FDP, what I feel a very good initiative taken by Professor Vasundhara and the institute, at least to deliver it by calling different eminent professors, speakers from the institutions as well as the industry, so that all together we can at least first address the issues and things in that line, so that at the end of the day, something can come up in the research front, which can be a value addition to the existing ongoing activities. Now coming to the topic, which is very much of paramount of interest, specifically when it's basically the natural challenges, which is climate change. It's not only the national challenge, not only the international challenge. It's a challenge of the nature, because nature is a dynamic and most unpredictable things what we basically face. Now, what are the different issues and challenges involved in front of climate change? Let us for that understand what is climate and what are the related facts. To start with, we should understand what is weather first, and then the climate and whether are these same or not. Now, weather basically refers to it's basically short-term periodic conditions of the atmosphere, such as temperature, precipitation, and a wind in a specific location. So weather basically a local issue, right? From region to region, from district to district, from village to village. I mean, if you take the very close distance, then definitely difference in the weather will be little. But if you take locations at certain distances, like you are in now Hyderabad, I'm in Kolkata, so you can find a lot of here it's raining, but humidity is very high. Temperature also is drastically, changing from hot to hotter and all, but still raining. So it's a variety of climate weather conditions we can observe, specifically also in your place. So I mean to understand weather is basically a short-term, variation over the atmosphere observed by the parameters of interest called temperature, precipitation, and wind and related factors. Whereas the climate basically is a long-term patterns and averages of weather over a region. So once you start recording day by day, you are recording the weather parameters. But if that recording is done for last 6 months, or last 1 year, last 5 years, that is called the climate. So the climatic variation basically impacts when the long-term changes, are happening and following certain patterns. Like that's what the climatic variation is going on. Like earlier, maybe 20 years back, exactly the months when rain used to, fall. Now, after 20 years, you may find that some of the months may be shifted from, if not highly shifted, majorly shifted, but still I believe that minorly it has been shifted because of the climatic variations or other way around this. Now, the just a second. Yes. Now, what we see, what are the different, climatic changes we basically observe? Like one comes water vapor. That's what the humidity is being controlled and the rainfall also varies. Then carbon monoxide, then methane and nitrogen dioxide. These are the different gases. Okay, later on we'll understand the greenhouse gases. When there is a existence of the greenhouse gases and increasing, then the balance of the atmosphere is being hampered, and that way we can see a lot of adverse effects on that. But all these, causal factors are automatically, intervened. No, human causes a lot of, distractions or something kind of activities which are not acceptable by the nature. But in effect, we find some of the impacts which that directly and indirectly affect our life, human civilization over a long period of time. Like what are the different other things which are being caused by the humans? Burning of fossil fuel. So all the industries, companies, oil companies and all, They are really busy with, extracting the or digging the earth and finding those oils and other things. And fossil fuel burning will release a lot of adverse gases, gases which are not, acceptable. Next, greenhouse gases. If anybody would like to ask any question and all, you can stop me and you can talk, okay? Otherwise, I cannot understand because you are behind my screen. I cannot readily see. At least you have to stop and talk, then only I can hear you. Next, the greenhouse gas. As I told you that carbon monoxide, methane, nitrous oxides, which are very much, let me check. Achha, okay. Good evening. Deforestation, it's very, I mean, all of us, a live example, all of us know it. A lot of trees are being cut, rather plantation rate is very low. So because of the deforestations, the dryness of the soil is very common, and that's what we are losing the environmental balance to some extent. A lot of diseases and all because of the greenhouse, again indirectly connected with the increase amount the deforestation, coal mining, industrial processes. All the waste products are being drained to the water, and then water gets corrupted, and so things. A lot of hazardous problems come into the picture. So when it was a fully nature-driven civilization, now it has become AI-driven civilization. Now this transformation from industrial revolution, 1.0 to 4.0 completed and yet to come 5, we are basically doing a lot of industrial automations, industrial revolutions. All are acceptable with, people will gladly will accept. That's what we are using a lot of scientific, enjoying a lot of scientific discoveries. But at the back end, when it is being applied, then sometimes we don't care about the waste things. And that's what waste management and so many things have become. Plus, like utilization of the plastic, how it is bad for us, all of us know it, right? Anyway, so these are some kind of background element, what I wanted to at least point out. What are the different impacts of climate change? What are those? A lot of impacts are there. Some of the impacts we are, again, atmosphere, because the atmospheric, conditions are being regulated by so many environmental parameters and factors. Simply, that's what global warming. What does it mean? That means Earth's temperature is increasing due to the melting of the, uh, icebergs in the different, ice countries and the seas, ice seas, the polar seas. The point is that this industrial evolution that increases the temperature, increases the amount of carbon dioxide in the atmosphere, and that may be one of the major, clues why this global warming has become so much of, point of, or why it's global warming. Globally, temperature is increasing due to, like melting glaciers leading to higher sea level. So the sea level height is increasing because of the glaciers, are being melted because of the increased temperature of the earth. Increasing greenhouse gases to the environment. As we know, deforestation and industrial, automations and revolutions altogether that contributing more and more greenhouses to the environment. New and widespread diseases due to warm climate. There are so many diseases that can attack the human being when temperature of the atmosphere increases. So that's so it's simple. You can see the skin disorders are more rampant during the summer season. But in cold season, skin disorders much don't happen. It depends. It's not linearly correlated, but that kind of impact analysis has shown, and that can be a one kind of a understanding that yes, diseases are also affected by the incremental value of the temperature of the atmosphere. Again, crops are being damaged due to sudden climate change and floods. What is very rampant in our country, varieties of states are being affected severely, a huge amount of, due to floods and the sudden climate change. Because this, crops, they can't tolerate if any kind of sudden adverse climatic situations affect these, that can be even some kind of crop disorders also happen, right? In addition to that, droughts, heat waves, extreme winters, storms, hurricanes, all etc. All these, factors, basically the outcome of different human caused environmental disturbances. And that's what nowadays so many things happens. Even technological advancement is there, but still we can't restrict so many things till now. And that is very, very, very alarming thing for all of us. Nowadays you can see even not in India, but a lot of landsliding and so many things are happening in the mountainous area. In the California and other places, you will find lots of jungles are burnt. So that means some kind of disbalance is there. Heat is more, and that is the reason why it is so, right? Why it is so. Wherever the tree, there is a green. Wherever is the green, then you will get more oxygen, less carbon dioxide. But still the jungles are being burnt. From helicopters, they're spreading the tons of tons waters just to, very difficult. It's a situation you can imagine. A lot of other things. Now, what are the different, this way list is more, but still at the same time we will think of, because how AI will be helpful, maybe one two case studies or example specific during address of my lecture, I will deliver it. Otherwise, it will be mostly theoretical, what I don't want actually. But to sensitize you, I told some of the things we should keep in mind. And also, as a researcher and academician, we should also focus that what we can do at the end of the day. Now, 7:30 পরে. Now, preventive measures. What are the measures we can, think of or are on roll? Reduce greenhouse gas emissions, of course. How that can be done? Because reduction, whatever the sources, if we can restrict to some extent, then at least amount will be reduced. Amount of, transmission of this emissions of the gas. So what are the sources? Basically, transition to renewable energy sources like solar, wind, and hydroelectric power. Nowadays also, focus is going to use the electric vehicle instead of the, oil-based vehicles, which will avoid the pollution. And that's what the intention is, that how to accelerate, how to implement at the mass level. Increase energy efficiency in buildings and industries, because energy efficiency needs to be, maintained such that a lot of power consumptions can be, we can restrict the power, uh, we can restrict the amount of power so that excessive usage of the power should be restricted, because the source of the power is again the either fossil fuel, the coal mines, and so many, under earth, whatever the natural wealth is there. So amount of wealth should be taken out less and less once your demand is less. So the balance, say supply and demand and supply model kind of thing. Electrifying transportation and promote electric vehicles. That's what the greenness, what the earth expects, that can come from the humans, a positive desire. Carbon capture and storage should develop and deploy carbon capture technology so that whenever the carbonization is happening, that should be captured. That kind of captured through different technologies, product, so that carbon emission should be restricted. We go for, when we use our vehicle, we go for pollution control. So basically, it's the level of the carbon emission is being tested, and based on the levels, you are given a kind of the permission or kind of a certification can be done. Now there is a limit. If your vehicle promotes more carbon emissions, then maybe it should be restricted or should be given some kind of advisory for its proper treatment and so. Third, protect and restore natural carbon sinks. How it happens? So basically, pressure and expand the preserve and expand the forests. So that means deforestation, which is a very much important, crucial, challenging bad habit of the human. That should be basically, that number of trees should be preserved. You should, cultivate the trees plantations in your home, in your village, in your mohalla, in your city, in your state, in your country. This way, expansion will happen. Wetlands and rivers that absorb carbon dioxide, because dry lands basically don't absorb much. Promote sustainable land use practices and reforestation efforts. Instead of deforestation, we'll promote reforestation. That's what we call plantation and so on. As a gesture of a lot of events, stalwarts, leaders, politicians, and all, professors, industrialists, all the people, government, they basically give the emphasis upon the plantation and do. It's a good habit, good practice for the many people who are, it's a kind of an event by which we are celebrating the culture of the plantation and all. Sustainable agriculture, I'll be talking later on how AI also is helpful in agriculture, and in our system also the artificial intelligence has been incorporated in order to promote the agricultural aspects. Right. Now, human intelligence and artificial intelligence. So to some extent, kind of different challenges we have seen. Okay, and we have understood to some extent and deliberated to sensitize what are the causes and what are the outcomes, and whether it's an adverse outcome, then how AI can help in terms of providing certain solutions, and what restrictions as a human being we can think of. Now coming to the emerging technology called artificial intelligence, and to make all of us understand, and already by now we have all understood how artificial intelligence is different from the human intelligence. Human intelligence, basically the natural intelligence, right? What we have, we don't know how do we have got. We are nurturing our inborn, whatever the brain we have got it. Then we are nurturing, and over the period of time that is becoming more, the brain neurons are getting more biologically strong enough, and it basically sends the information through sensory organs and then do process and activates, and that's what we human being are having the cognitive factors. We can sense, we can see, we can hear, and so on. We have feelings, perception, and so on. But the artificial intelligence, basically the intelligence which is being made artificially, following the pattern of the mechanism of the human intelligence in a mathematical way, so that the computer can understand. In a more simple language, by intelligence we mean its ability to solve a problem. When we call human intelligence, it means when the human uses their intelligence to solve a problem. Next, artificial intelligence, when a machine having the ability to solve a problem. That intelligence is called artificial intelligence. Now, this AI concept and its evolution, okay, it was inceptual, it was revolutionized, discovered by Alan Turing, the birth of AI in the year of 1950s and early 56. So it is defined again the science of making computers to perform complex tasks, because the machine will have the ability to solve a problem. It's a simple problem to complex problem. As long as the problem is complex, then the complex AI techniques will be also over a period of time. That's what it has been developed. Now, machine learning, basically a major part of the artificial intelligence that focuses on the methods that learn from the data and learning from the data and make predictions on the unseen data, called machine learning. So in this onion-like structure, you can see like a Venn diagram. So machine learning, the yellow region takes the majority of the AI regions. And another red circle you can see, it's a deep learning, which is subset of the machine learning, where the learning takes place in a deeper way. Now, by deep learning, deeper means some kind of difference definitely should be there. Otherwise, from this diagram, we can tell that all deep learning algorithms are machine learning algorithms, but all machine learning algorithms are not deep learning algorithms. That means, where is the difference? The major difference is that in case of machine learning, we human beings need to be involved to extract the features manually, characteristics. So that means humans' intervention is very much required in case of machine learning for feature extraction. But in case of deep learning, and what is the advantage? Advantage of human-based feature extraction is that human intelligence is, human intelligence is used, and for that, the features are priorly understood. What are the set of features? So fixation of the features are almost done by the human being. Now, the human beings use some mathematical techniques to extract the features. Like if it is a texture feature, use some kind of gray level coefficient matrix, co-occurrence matrix, GLCM method, Oblate transformations, Gable filter, and all. If they are texture-based methods, some statistical methods also are there. Mathematical methods also there. Geometric features. So to extract geometric features, texture features, morphology, color features, majorly these three level of features already understood by the human being, and human beings will use these different mathematical measures to extract those features, and then these features will be input to the model for training from the data. And here, this is major advantage. Another advantage that in conventional machine learning, you need data, of course, but not always large number of data is not required much. But in case of deep learning, first you need large amount of data, which is not mandatory for machine learning, but for deep learning it is mandatory, because here human intervention, humans involvement is not required, because here the features are automatically will be extracted in terms of using convolutional filters. So once no human is there, that time you need more data. Why? Because from more and more amount of data, the filters which are already designed in the algorithm, it will automatically extract the very atomic level, very fine features, and you have a large amount of features. And that's what for proper training, since large amount of features, basically the parameters, then you need, that's what in the training means optimization, learning from the data means training the model. Model means function of variable and parameter. So once you are feeding with the large number of variables, a function having large number of parameters or large number of features or large number of variables, definitely you need large amount of data. That is the fundamental difference between machine learning and deep learning. But it's very, very important to remember while you are going for using deep learning. Many times the question comes, why you have not solved your problem at first level by trying with machine learning? Why straight away you have jumped to the deep learning? Many times because of the paper and for the sake of research interest, people do it. But many times reviewer put these questions to the authors. Many times we give correct answers. Sometimes we also become confused because intention is to get our paper published. Anyway, so this is the fundamental concept of AI, and all machine learning, deep learning are basically the uh, integral part of AI. Now, what are the different advancements happens in case of climate sciences where the AI models have become very much useful? Once we talk about data-driven climate models, there are varieties of climate models. The model basically the algorithms which are to be trained with the data, and that's what it is called, data-driven climatic models. Process-based climatic model, when we observe data set for a longer period of time, it's basically a process. It's happening over a period of time. Then the climatic models dynamically will be updating its, the parameters of interest, and that way things will be considered as process-based climatic models. And mixed up these will the hybrid models. That will help basically energy sector, industry sector, building and science, infrastructure sector, real estate sector, agricultural sectors, farms and forests, and transportation sector. So how this adoption helps? Basically, it will help for disaster prevention. Disaster prevention, any kind of natural things happens, maybe the long-term impact is there due to the climatic change. Social impact, so that mindset of the people, it will create an influence over the people, and ecological impact, because other than human, a lot of other animals are there in the ecosystems. So the whole ecological system also, should be properly maintained such that the balance in the system, natural system, should not be much hampered. Anyway, you can see one, this, I don't know, it's still open. No. AI intelligent applications. How artificial intelligence, have become an integral part of the intelligent applications. If we start from recent, nice incident, that is that space station, International Space Station, using SpaceX, the people are going and coming. Nowadays, like it has become very easy, like you are moving by flight from Hyderabad to Bombay, Bombay to Hyderabad. Now we are, with respect to Earth, we are moving here horizontally, and there its movement initially horizontal, then through different orbits takes its projectile, like the projectile based calculations based on which the humans are going very fast. Just a second, please. Okay. Now, whatever, I mean, this link, one video I wish to share. Anyway, maybe we'll be showing you at last. Here, what you can see that different data in terms of satellite images, precipitation in the atmosphere, okay, surface runoff, soil moisture, captured by remote sensing, means different kinds of sensors and cameras. Then you have a nowadays, IoT systems have come into drone-based camera that also takes care of the imaging part. These data are collected and sent to the cloud. Different climatic models are already pre-trained, but with the new set of data, when the it's called transfer learning, initially training already done, but the pre-trained model will be used for these data sets to predict about the different prediction, monitoring, surveillance, and so on kind of activities can be tasks as a part of the climatic changes. Now here, what you can see that uh, satellite imagery and sensor data basically are used nowadays to monitor the deforestations, so that in a huge region, very difficult to, no need to, no need to see one by one forest, the trees cut or not, rather a region and region, and it should be time to time also need to be looked into to track wildfire populations. That's what that example I had already told you, that wildfire has become nowadays very frequent, which is unexpected, but because of the climatic change with respect to the global warming and other factors, then we see that its chance has become increased. Now, to predict these data sets are used to train the climatic models in order to predict natural disasters like forest fire and floods. So this is real-time monitoring enables quicker, more effective responses to environmental crisis and better conservation strategies. In climatic modeling, basically AI models are extensively being used to analyze large data sets related to climatic parameters, greenhouse gas emissions, and other environmental factors. Where after analyzing, this will be used for extreme weather predictions. Once you have a long-term data, okay, long-term data, so that time, like time, it's many times it's a time series data. So people use a lot of auto-regression models or auto-regression moving average models, depending on the stationarity, stationarity of the data set. But over a period of time, long period of time, some patterns sometimes being using moving average method can be understood well. Once that is understood, then we will be in a position to at least deliberate on that. Here, what you can see, AI algorithms analyze weather data to improve the accuracy of predicting extreme weather event conditions. Basically, in climate and weather, it's a local issue, it's a global issue. You have the all of algorithmic different types of machine learning, deep learning algorithms today available in bunch of in a sequence of models. What really made the humans to use, so that time to time we can all think about how to do that. A lot of regional data already available in the metallurgy department in that particular regions. So if you can collaborate and try to explore what are the models they have already used, any other advanced models, day by day AI techniques are being improved as data driven, so that we can have a varieties of uh, human heuristics, what I will tell, because papers have been published, but still research is going on. That means you are still would like to do something new or novel, which will help others. Now, machine learning, deep learning definitions and their difference I have already told. With this flowchart, a very good example to, to mention about the difference between machine learning and deep learning. How weather prediction model using AI and generative AI people use. You can see we have a lot of sensory data about multi-sensor data fusion, data collections. So lightning is there, then satellite is there, then we have the model fitted pseudo codes are there, and we have a weather, weather data is there. So quite blurred this slide, but this is the image actually in PDF format. So anyway, I hope the flowchart, the essence of the flowchart, if we can understand. Now, the machine learning, the network is showing basically the convolutional either machine learning, if it is a feature based, or if it is a fully directly data driven, then convolutional neural network, which is nothing but the deep learning, all we use for predicting the weather, whether storm level, intensity of the storm, the direction of the storms, and so on. Now, how it happens at a different, conditions, climatic conditions over a period of time, you can generate some kind of heat maps during the training to see from the severely attacked region to the less severely affected region to the less. So this basically over the period of time that this time series data, if we properly feed, there is a neural network called CAPSNet that takes care of this data set, and finally it basically uses different filters. You can see initially 32 filters, 5 by 5 input image, then 64 filters. So by increasing the number of filters, basically we are extracting more and more finer abstract features or low-level features to the mid-level features, and then mid-level features to the higher-level features. Like for a building, if we first extract low-level features, is nothing but the lines and edges and angles. These are the low-level abstract features. Then we go for mid-level features. If you connect the line and angle, it will be like the perimeter of the buildings. And then if you go for high-level features, we will try to understand it. So whether it's a building or it's a room, it's a hotel, or it's a car, it's a phone, like this way. So that, but low-level features are the most atomic level of features being generated as a first, layers of mostly the convolution layers that generates called feature map. And then it is input to the maybe some kind of a encoder decoder we use for generating certain distributions if it is from the noise, so that the artificially the data when fitted with the original distributions, the original probability distribution, and the artificially generated synthetic data, and the distribution of the data sets, when the distributions are remain same, whether or not that we see mathematically, we use the scale divergence, Kullback-Leibler divergence method to see the difference between the two probability distributions. Anyway, and then once we are happy with the convergence and the controlled error, then we can make use of that fitted model for prediction purpose. It is one example, again, in the agricultural area, which is part of of course, our natural resources, where how artificial intelligence, as a case study, I'm just throwing how AI has been implemented and its evaluation over the agriculture. So step one, you can see manual era when farming relied on human and animal labor of all tasks. Of course, that era we must have seen our childhood. Second, basically mechanization era when tractors and different machinery, machines have been introduced that helps to reduce the amount of labor and increase the productivity, because more human means more error. Machine has to be efficient enough, and then so you start started using the machines, and we know all the different machines required for agricultural productions. Third, green revolution, when Green Revolution in India happened, then high yield seeds, that means hybridization of the seeds at the crop level from the biological point of view, fertilizers and irrigation transformed for food production. That basically the basis for the Green Revolution, and people have started using, and production has been increased significantly, as we all know. Now the era where we have entered called precision farming era. So in the precision farming, how farming can be done maintaining its precision. That means you will be using different technologies like GPS, global positioning systems, then sensors for sensing the informations in terms of its data. Third, satellite data enabled accurate and efficient farming. So you also use, like in soil testing, then the how much of amount or quality of the seeds, then the productions, all are connected to the productions. That's what precision farming. Now it is drone based, and different, especially South Africa, some examples have come up and YouTube are available, nice things that we can at least learn, see and learn, and if we find it is applicable subject to the improvement of the productions, we can always think of that. We means I'm talking about the people at the grassroots level, mass level, who are at the endpoint user. Now, different sources of the data, even in case of the agriculture, what you can see, remote sensing data, where the maps, this data basically gives the information about the land usage and crop health. Then weather data that provides insights into the weather patterns and forecasts based on the parameters of interest, temperature, precipitation, basically humidity, and other kind of factors which are available. Soil data, because soil quality monitoring very important to understand the soil conditions and its nutritional levels, because we put different fertilizers for enhancing the nutrients levels so that the plant can grow in an appropriate way. Next, you have a machinery data. We use a lot of equipments. We should monitor their performance. Market analysis, market data, which basically gives us different kinds of trends and the prices, the demand and supply, crop data, and so on. So related to the agriculture, which is part of the cultivation and all, what do we want should come naturally, more and more, beneficially. That basically, just to say. Okay. Now, traditional versus modern systems. Characteristic-wise, if you see the difference, land preparations. In the traditional farming, the manual plowing with animals we know, but in modern farming, we are using GPS-guided tractors and machinery. So whatever need that kind of digging and kind of a tractoring, which will help specifically to prepare the soil, fit for the that cropping. Seed selections, locally shaped seeds in the traditional farming, but in modern farming, high yield, hybrid, and genetically improved seeds are being used. In the case of irrigations, flood irrigation, that is the traditional farming. In there we can see, but in case of modern farming, we see drip and
కెమెరా పెట్టట్లేదు కెమెరా పెట్ట
So what you can see over here, a lot of such factors maybe can be seen. So application of, so it's basically AI based. It's a part of course, data science, and why I'm talking data science, because all the data we'll be using, starting from the data generation to data processing and then implementations, interpretation and implementation, and feedback generations. Because in case of weather prediction and planning, we use past and real-time weather data to forecast conditions and harvesting effectively. Pest and disease detections, AI-based detection is very much popular now, specifically from the images captured using different cameras, whether it's a normal digital camera or it's a kind of a hyperspectral cameras, depending on the objective what we are looking for. Smart irrigation, where we integrate Internet of Things based systems, which basically helps us for continuous monitoring, surveillance, so that and also the automatic switches for pumping and other kind of activities. So precision farming, where we use drone imagery showing crop health monitoring and so on. Here, what I can see that one such puzzle, it's one startup company. They developed microclimate, and AI tool that is based on microclimate forecasting system, which is tailored to individual farm plots. Right. One of the India's earliest private weather data providers, of which is operating a network of IoT weather solutions. What you can see, that's used for weather prediction and planning here. Internet of Things, all of us know. I think this was a very nowadays hot area where you can connect the people only through different gadgets, and we can get the best benefit out of the interconnectivity and the different gadgets which are being connected through this network, so that you can get a seamless transmission of the data for proper analysis. This IoT in agriculture, it's very kind of smart village if we have, where we can expect so, and automatically things will move even no human is there. There are different devices to have devices. Basically, sensors are integrated for light, motion sensors, soil moisture sensors, and to understand different weather conditions like temperature, humidity, wind, and rain, measure the natural calamities, and the air pollution, dust and pollution gases. Nowadays, a lot of elements that basically that corrupts the that pollute the different air pollutants, that taken care. Then actuators that basically uh, generates the lights and electric bulbs, electric switches, and other so on. This is to minimize. Yes, understanding how wireless connected centers can help in plant care. So you can see the purpose is specific sensor are connected to wireless modems. They send periodic environmental data to the user over internet. He or she analyzes this data and remotely adjusts the plant's environment. So basically, if you should have the proper sensor which will sense the data and send you over a network, so that the user can avail the data set time and remotely adjust, remotely generate the inference. So, and this is the flowchart where you can see the greenhouse monitoring is taking place in terms of alerting, in terms of sending the alert message through internet, and critical equipment needs to be controlled and so on. So in the smart greenhouse at the application, what I can see, greenhouse sensors like monitor, control, communicate with the internet. That's what we make the system more smarter, because in the agriculture, moisture, temperature, water, and light, these are the integral factors which need to be constantly monitored, and through internal monitoring from your office, or any tree you are on tree or whatever, all these things can be very much well understood, so that you can inference accordingly. This picture can show that wireless connected centers, irrigations, how these are beneficial, so that based on some kind of a voice activated or text activated commands, or automatically some kind of the water flow in the fields can be maintained, because unnecessarily water wastage also is not encouraged. This is one how field connect. So maybe this was published in BBC News. So just I am demonstrating this video for you.
Businesses with AI. While the only AI you know is Chat GPT. Let's be real, most people over. So we talked about groceries, the food we buy off the shelf, of course, is all cultivated and grown on farms. And if we head to India, 50% of the workforce are employed in agriculture, and a growing population, now 1.4 billion, are dependent on the crops produced. But traditional methods are now making way for new technology that promises to make farms more efficient, productive, and profitable thanks to artificial intelligence. Our Chandan Chakraborty reports.
For generations, Indian farms have been sown and tilled only.
So BBC has broadcasted news on our.
But some, like NITTTR, are trying out something different. With sensor devices on his vineyard that check weather and soil health, and uses artificial intelligence to figure out when to water the crops, add fertilizer, and tackle pests. Nitin then receives a precise advisory on a mobile app.
So you can see
how now it has no groundwater sources, and we are growing these vines with the water that we purchase from outside tankers. With the help of this AI data, we are now able to irrigate them only at the crucial stage, and that's helping us to save around 50% of the water that we used to give before.
Built in India's Silicon Valley, Bangalore, by startup Fossil Agritech, the service has led to a near 25% boost in productivity on crops like grapes and guavas. Informed decision making is only one part of the solution to improve productivity, but weeding out inefficiencies in the existing age-old agricultural practices is also crucial. AI-powered robots offer a solution. This one is equipped with precision cameras that scan the ground in real time.
You can see how precision camera basically.
The way spraying is done in India is on an acre level. And our mission is to boil that down into a plant level decision. Just by spraying only on the plant, we are seeing a 56% savings.
Improved rural digital connectivity and government support for agri-tech startups has pushed farm innovations. But even now, just 2% cultivators use tech in farming.
We really need to enable the digital public infrastructure. And second is the public-private partnerships. India will always be resource constrained. We possibly are perhaps lowest in the yield level. We possibly are pretty much constrained on finance and insurance services for the partners. And that's where the gap needs to be filled up with AI.
Data-driven agriculture promises profitability, but will need considerable time and investment to reach majority of India's farmers. Chandan Chakraborty, BBC News. Bangalore.
So you can see how precision farming, how basically people are using AI. Basically, just a second.
You must be having this full.
Let me see.
For home interiors.
Okay, so hope this slide is all about. You can understood from this BBC news broadcasted the real in our India on startup company is working on that and how beneficial they have demonstrated. And that's what at the international level it was, broadcasted. Now, Green IQ system has 3 components. So this is another, AI-driven solutions for smart garden hub that controls irrigations, specifically the restriction on the unnecessary usage of the water and so on. So it's a basically you can see this visual flowchart helps you that a mobile app which will be used connected to the Wi-Fi and cellular data. Then Green Eye Cloud is the through which the mobile is connected, and then it basically different sprinklers are there. You can see that and irrigation valves which will be on or off based on the command depending on the area where the water is required. So maybe that analysis will be done based on the sensor data. Once data are available, then after analysis, the level of water level in that particular region can be assessed, and depending on the threshold at the algorithmic level, instructions will be given so that whether man or machine, but amount of how much water should be given. If it requires 1 liter, you should not put 5 liters. The connected tractor, the tractor revolutions, you can see how the smart tractors and when smart tractor is connected under the network, IoT, internet, and then how it works well. Now, this basically, I think the same example or different example just to show you.
So you changed the lock?
How this
Daniel Alameda is a 3rd-generation farmer in the Salinas Valley, where he grows thousands of acres worth of broccoli, cabbage, and lettuce, among other things. Like with any farmer, the scourge of his operation is weeds. And about a year ago, Alameda turned to a cutting-edge solution, an AI-powered weeder. The device, which attaches to the back of his existing tractors, uses high-resolution cameras and sensors to automatically detect unwelcome plants and spray them with a precise dot of herbicide.
So what the driver sees in the cab is real-time footage of what's happening. The crop that's there and the weeds that we're trying to remove. The driver sees the machine analyzing the data and then taking the shot. You're seeing decisions made in real time. We definitely had no AI not that long ago. The owner, operator, manager was the AI. We were making the decisions, but we realized quickly about 10 years ago that we could use software to make better decisions. We are trusting AI to make us better, more efficient, and faster.
We're starting to kind of notice AI getting a lot more penetration on farms across the country. Farmers are using things such as drones, autonomous plows, crop sprayers that
autonomous robots to heat farms with manufacturers.
And a lot of them are using data collection to just suck up all of the information from the farm. John Deere is
so you can see how AI in which way it's becoming very much fruitful
autonomously. So I think this stuff is here to stay, and there's really not a lot of other ways to just kind of get it all done.
At UC Davis, researchers are using AI in another way, to better understand individual crop genes, so they can make
genetic advancements
changes in the environment.
What you're seeing here, the first prototype in half a day was this thing, a bird box, right? It's one thing to collect the data. That part's actually kind of easy. You go out in the field, you collect the data, but then you generate this massive data set. It's like, imagine if you took your camera, instead of just taking red, green, blue, which is what it does now, took another 400 bands of light. So it's this cube of pictures. And so what you end up with is this massive
different spectral bands generates different images.
That's where artificial intelligence comes in. Scientists at Davis are training computer models to detect everything from the size and shape of a flower to the direction that a leaf is pointing.
plant breeding is really interesting application for AI.
Yes.
Let's say we're working on bees. In this example here, what we have is over 330 different genotypes of beans that have been planted out in a field. So what you're looking for is like maybe some of these have really big beans or certain patterns, or the protein content is high or the fat content is high. It's just really hard to measure and see and score by humans on the ground. And then if we can process all that data.
I hope you are getting something. I mean, just I tried to present you the activities
Farmers from 50 years ago, if they
people
saw
have
what
done,
AI could
and they have showcased.
Using computer vision, we can rapidly accelerate that process of searching through all these possible children, right? The traits that we care about. And so it can take us from taking 30 years to breed the crops that we want to maybe taking 3 years. The fact that we can then take something that seems so state-of-the-art and advanced, like AI machine learning, and bring those two.
Maybe a little bit, I
think
can
there's
fast
something
forward.
really magical about that idea.
If you were born between 1980 and 2000, your asset max like a solid term plan.
What's the right time of year for me to begin setting up my raised bed nursery?
The best time to start setting up your raised bed nursery for transplanting paddy saplings.
The AI tools being created in collaboration with the team at Davis aren't just about using AI to process and analyze data. Rick and Gandhi has been building a large language model app for farmers in developing nations.
So the small scale farm we work with are primarily
LLM models have been used, which is natural language processing,
specifically in India, Kenya,
for
Ethiopia, Nigeria.
interactive
You could say that what
communications,
is a type of
so that the
for
farmers can get the
They're
instructions.
looking for generic Wikipedia or ChatGPT answers. They're looking for information that is proximate to them and location specific. There's a bunch of challenges that we face. There's a need to support all the various languages and dialects that farmers speak. They don't use scientific terminologies like kilograms or percentages or chemical names. We need to be able to train these systems for speech to text recognition, for their local colloquialisms and vernacular. And also not just speech to text, but also text.
So this is the application of the AI and all.
Be able to access.
We are at the beginning, it's moving quickly, and I think we come back and revisit this 3 to 5 years from now, we're gonna be pretty blown away.
Just housekeeping, some of the things.
It's got spatial AI that allows it to solve the where problem. Where am I? It also solves the what problem. What am I looking at? Is it a carrot? Is it a weed? What type of weed?
Initially, people thought that autonomous navigation would be a really valuable thing to bring to market. The thing that you have to understand is that it's not the navigation of the tractor that's the job they're worried about. It's the 100 people walking behind the tractor that are opting to go work at Starbucks or Walmart or in a data center labeling images. That shift in labor is the one that's causing them heartache. Efficiencies we need in ag are substantial. In the next 50 years, there are.
Maybe later on we can see more, but very interesting. I find really how people are, working. I think we theoretically sometimes talk about, but at the implementation level, if you look at least we'll be motivated, energized to do something in our own. And that way, really, it's helpful. This is another video. Also, I will prefer to show you.
So we talked about
it's very good. It's a 3 minutes video. If you listen carefully.
It's all cultivated and grown on farms. And if we head to India, 50% of the work.
No, this is the repetition. So please, sorry.
For generations, Indian farms have been sown and tilled only with traditional know-how.
No, this is a repetition. Sorry. Already I have talked about. Yes, here AI and mobile-based pest and disease detections. That's what you have seen. So Agrio, formerly known as Silog, that uses deep learning to identify over 500 crop diseases and pest infestations by a mobile app. There is another company, Plantix. It's basically the crop advisory app that, sorry, Pete GmbH Germany, that developed one mobile app or a crop advisory app that diagnoses pest, diseases, nutrient deficiencies from the uploaded images. Looking at the leaf of the plant, can the AI tool, AI detect the nutritional deficiency? And that's a And then only, because the farmers used to, do all such activities based on their long-term experiences, imaginations, and expectations. But once you have the scientific data, and then only we need some kind of concrete technology and tool that can process, and at the end of the day, it can give about the idea and in a quantitative manner that yes, exactly how much deficiency is there and what should be the recovery, what is the best particular vitamins and all should be given. Drone services and AI-based remote monitoring have become also very, very much important. Where Bharat Rohan that deploys from India that deploys hyperspectral drone imaging, because drones is used to grab the image, where the hyperspectral cameras are integrated. That helps the farmers to detect early stage disease outbreaks, pest infestations, and nutrient deficiencies long before visible symptoms appear. Because in a conventional farming, when farmers basically recognize the disease after manifestation through different symptoms, but before the symptoms, much early before the appearance of the systems, if it is, we get the signal that yes, that particular infection is there, then that should be, because visible informations may not be there, but the hyperspectral at the different spectral level, maybe the initial early onset of the disease that can be captured in terms of their spectral differences using hyperspectral camera. And that way, basically, this image show you that taking the picture, the hyperspectral camera, the drone is there, snaking this camera and immediately detected where the infections and other things are there. So majorly drones are used in, AI-driven, of course, in agriculture for monitoring purpose, like crop monitoring, animal monitoring, building and equipment monitoring. What are the, purposes, actions to be taken? Let's say mapping, geomapping, the spreading, and so on, or diagnosis of the disease, water stress, crop yield, soil erosions. All things happens, of course, once we have the proper data and the proper research forum for developing the AI algorithms and so on. So honeycomb, agricultural drones and data solution providers, where the survey said that large amount of land detect the areas of stress and monitor irrigation systems. So let's see one such video for again.
No experience in data science, no jobs in data science. Not true. Open doors to data science roles with this set.
This is also very beautiful. I love this PPT, so I'm showing you. So remote sensing technology has become very important. 5 different applications of remote sensing used in precision agriculture. One is crop monitoring, where you can see how hyperspectral camera send the images. Here, crop height, that is very important for timely incorporations. It saves time, money, and increases productions, of course. You can see soil moisture monitoring. Soil conditions will be evaluated. Data helps to decide when and how much water to irrigate their crops, and accordingly the amount of water spread. And it provides huge amount of soil data, and this soil data basically helps to understand nutrient management. Data helps in determining the areas of the field that need calculated distributions of these things and so far. Wastage of fertilizer also minimized. And the fields you can look at wind detection, and it maps the weed growth. Preventive measures to control weed growth and protect crops. How much productions that can be estimated helps farmer to predict the amount of yield. So that's how the things to make better decisions on predict planting schedules, harvesting, and marketing. So this is a very, very nice, very short this geospatial world. This video is very, very popular. I mean, I personally like this, so I have just shared for you. And this way, so many things are there. You may be bored enough, but I hope during this evening period of time, people, when the brain is loaded, I think this kind of, yeah, so we can. Okay. So what you can see that how different tools and techniques people using and lot. So in the precision farming, we do the things from varieties of angles for smart sensing and monitoring. Then we go for smart analysis and planning, and then go for smart control. These are also, this is a Kisan project, okay, Kisan project, a crop insurance using space technology and a geoinformatics launched in 5th October 2015 by Dr. Sanjeev Kumar Balian, Minister of State for Agriculture and Farmers Welfare. So how apply? There are different states covered, one district each of Haryana, Karnataka, Madhya Pradesh and Maharashtra during Kharif season of 2015 and 2 districts each of these states during Rabi season of 2015-16 on pilot basis. It's a pilot project. The project emphasizes uses of space technology and geoinformatics, GIS and GPS and smartphones technology that is called geoinformatics, along with high resolution data from drone-based and aerial view imaging data for delivering the timely and accurate data on the state of the agricultural crops. So Dr. Balian also launched an Android app called Health Storm app. It is designed by ISRO, National Remote Sensing Center, Hyderabad, from your region. This app will help in real-time data collection about hailstorm occurrences, along with the photographs and geographical coordinates. Right. So this will help government to get real-time data about the hailstorms, which will be collected through the agricultural department officials of different states. This will support in deciding the crop loss more objectively and in a very fast way. So this is the bhuvan.nrsc.gov.in. If you go to this portal developed by ISRO and Government National Remote Sensing Center, Hyderabad. So you can understand, in fact, how our country also is on roll for using such kind of nice inventions. Let's say move on geospatial map and of different regions to assess about the factors like this. So what is the conclusion that past, when you have the in 19th century, the plowing, the GMO, the GPS management, then present, confused for worldwide data, overloaded with the data. Future, we are going to connect by the AI, IoT devices for smart farming and smart doing as a part of our environment, and which, of course, contributes in the climate change. With this, I thanks all of you for in listening me high patience, because now people must be having some, I mean, evening work and all, but all of you have, I'm very much thankful for listening this lecture, which is, I think, from the perspective of the climate change and all, India as a whole, taking the lead over the world to do something and to deliver something, because we all believe that the world's, greenery, world's environment, that's what World Environment Day is being celebrated. And India can be the pioneer in this, in terms of, giving the message to all the countries of the world. Look, the technology, whatever has come, we will use, we will do. But at the end of the day, we should all together should lead the healthy life, and the civilization, generation to generation, should, remember us what we do for the future, for the nature. Thank you very much, all of you. Thank you.